Dear students, we are going to discuss about capacitors. What is capacitor? Capacitor is an electrical device which used to store electric charge. Capacitor uses its plates so as to store electric charge. Capacitor has got two plates, plate 1 and the plate 2. In these plates, we are going to store electric charge. We have different types of capacitors. We have paper or plastic capacitors, we have mica capacitors, we have electrolytic capacitors, we have variable capacitors. We are going to discuss much about these types of capacitor when we have them in hand. But in this presentation, we are going to discuss about arrangement or combinations of capacitors. We have got two arrangement or combinations of capacitor. We have capacitor in series and capacitors in parallel. Okay, so we're going to discuss about combination or arrangement of capacitors. These are capacitors in series. As you can see, this is capacitor 1, this is capacitor 2, and this is capacitor 3. So this is a symbol which used it to represent a capacitor. So instead of drawing a capacitor, we are going to draw this symbol, which is plate 1, plate 2, to represent capacitor. Okay, this is series combination of capacitors. As you can see, in series combinations, they are going to use the same charge. They are going to store the same charge. So the charge which will be stored in capacitor 1 is the same as the charge which will be stored in capacitor 2, and will be the same as the charge which is stored in capacitor 3. But there will be going to be a drop of potential difference in each capacitor. This is potential drop in capacitor 1, this is potential drop in capacitor 2, and this is potential drop in capacitor 3. But this is the total potential difference, which should be equal to the potential drop in capacitor 1 plus potential drop in capacitor 2 plus potential drop in capacitor 3. From the definition of capacitance that we are going to see it later, is equal to charge stored on the plates over potential difference. So simply because we are going to have the same charge stored, therefore potential drop at capacitor 1 is equal to charge stored over capacitance in capacitor 1, and potential drop in capacitor 2 is equal to charge stored over capacitance in capacitor 2, and potential drop in capacitor 3 is equal to charge stored over capacitance in capacitor 3. So when we substitute it to this equation, we're going to get that charge stored over C is equal to charge stored over C1 plus charge stored over C2 plus charge stored over C3. So as you can see that here we have charge, we have charge, we have charge. We can eliminate it out. So we are going to remain with 1 over C1 plus 1 over C2 plus 1 over C3. So this charge is going to cancel with this charge. We are going to remain with 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. This is the general formula which is used in series combination. This is the total capacitance or equivalent capacitance. So if you want to find equivalent capacitance or total capacitance in series combination, you're supposed to use this formula. Okay, students, let us now see capacitors in parallel. As you can see, this arrangement in parallel. This is capacitor 1, this is capacitor 2, this is capacitor 3. So in parallel combination, capacitors are going to store different charges, but they are going to use the same potential difference. As you can see, that total charge is equal to charge stored in capacitor 1 plus charge stored in capacitor 2 plus charge stored in capacitor 3. So from the formula that capacitance is equal to charge over potential difference. So we have to make charge the formula, the subject of the formula. Okay, this is charge is equal to CV. Okay, this is charge 1 is equal to capacitance in capacitor 1 times V. Charge 2 will be equal to C2V. Charge 3 is equal to C3V. So we're going to substitute it in this equation. We're going to get that CV is equal to C1V plus C2V plus C3V. Okay, this V is obtained in both, so we're going to eliminate it out. So V will be out, brackets C1 plus C2 plus C3. So this V will cancel with this V. So we're going to remain with C is equal to C1 plus C2 plus C3. So this C is equivalent capacitance or total capacitance. So this is the formula which is used to find the total capacitance in a parallel combination. Okay, dear students, let us now discuss about capacitance. As you can see that I told you that C is equal to charge over potential difference. What is C? What is capacitance? Capacitance is ability of capacitor to store electric charge, or capacitance is the ratio of charge stored on the plates to the potential difference across the plates. And we have a number of factors that affecting capacitance. Okay, let us now see factors affecting capacitance. We have area of the plates. This capacitance increase with the increase of the area of the plates. So when the area is large, this means that capacitance is increased. The ability of capacitor to store electric charge also will be increased. Okay, we have distance between the plates. Capacitance increase with the decrease of distance of the plates, or distance between the plates. So whenever the distance is reduced, the capacitance will be increased. So when we combine, we are going to get that capacitance is then proportional to area and inversely proportional to distance. So we are going to remove this proportionality sign. We're going to get with capacitance is equal to constant area over distance. So this constant, it is the electric constant, because capacitance also depends on the nature of the material which is used to make a capacitor. So whereby C is equal to capacitance, this is the electric constant, this is area of the plates, and this is distance between the plates. This formula will be used to find either of the following. You can find area, you can find distance, you can find the electric constant, and also you can find capacitance. Okay, as you can see that there are some formulas that we're going to use in solving questions, and you're going to solve some exercise by using those formulas. Thank you.